It is time for lesson 4 of the Year 7 Earth topic. We are learning about the Earth because that's where we get our natural resources from. We can use chemistry to change it into useful products, and today we're going to look at the useful products which can come from air. So we're going to look at the Earth's atmosphere and what is air made of is the driving question for today's lesson. And as part of this lesson, we will revise the words mixture, element, and compound. Okay, so what is air made of, and what do we mean by the Earth's atmosphere? Now let's imagine a space shuttle travelling up through the Earth's atmosphere towards outer space. What would it actually move through? Well, here's a diagram of the Earth's atmosphere, and it is all made of air. But what happens is, the higher we go, the thinner the air gets. So a space shuttle orbits at around 350 kilometers. To put that into perspective, there's Mount Everest, the tallest mountain in the world, down at the bottom of the diagram there. Aeroplanes fly here about 6 kilometers. Ozone layer, what that means is it's still made of air, but the air in this part of the atmosphere contains a bit more ozone than usual. Okay, that helps to protect us from ultraviolet radiation from the sun. But it's still made of air, just with extra ozone in it. But as we go higher and higher, the air gets thinner and thinner and thinner until there's practically no air left. That's called the exosphere, and that's where we think space begins. But there's no exact boundary. Oh, there's some weather down at the bottom of the diagram, where the clouds are, the height of the clouds. There is no exact boundary where the atmosphere becomes outer space. It just gets gradually thinner and thinner, further from the surface. And all the way up, it is made of air, a mixture of gases. Right, now here is an experiment to investigate different gases, including the gases in air. So we're going to see some test tubes of gases coming up in a moment. And here we go. Right, now let's have a look what happens to this gas when they put a wooden splint inside it. It goes out. Right, now that is nitrogen gas, an unreactive gas. Carbon dioxide does the same thing. It will extinguish a lit splint. This stuff is liquid nitrogen. It's really, really cold, about minus 200 degrees. Right, so that is nitrogen that's been cooled down to a liquid. It's incredibly cold. It's so cold, it can instantly freeze a flour. So that flour now becomes solid because it's been instantly cooled to minus 200 degrees. Now we can make use of this stuff, liquid nitrogen, to investigate air and find out what it's made of. So here is an empty test tube. There is only air in this test tube. That's all, nothing else, just air. But they're lowering it into the liquid nitrogen, which is minus 200 degrees. And what happens is the air turns to liquid. That test tube is going to contain liquid air. The air condenses from gas to liquid because it's so cold. That's liquid air. Air that's been turned into a liquid at about minus 200 degrees. Then what they do is start a timer and just let it warm up. Okay, and as it warms up, the gases in this test, or the liquid in this test tube, is made of a mixture, and it's going to start turning back into gas. Now, the first gas that comes off makes a lighted splint go out. That is nitrogen gas, an unreactive gas. So at the moment, nitrogen is boiling off this test tube because it's warming up and turning back into a gas. Then, a little bit later on, it starts to make the lit splint glow and burn even more because oxygen is given off. Right, here's a glowing splint. In oxygen gas, it relights. Oxygen makes things burn. Okay, so to begin with, the test tube gives off nitrogen. Then it starts to give off oxygen. And that shows us that air is made of a mixture of nitrogen and oxygen. Okay, so let's go through that a bit more step by step. Air can be separated into different gases because it's a mixture. Each gas in the mixture has a different boiling point. That means it will boil at a different temperature. And in the experiment, air is cooled down until the whole mixture becomes a liquid. Then it is allowed to warm back up again. As it warms, the chemical with the lowest boiling point turns back into a gas first, and that is nitrogen. So that will boil almost straight away as the mixture starts to warm. Okay. Now this technique, separating a mixture using boiling points, is called distillation. We normally do it on liquids such as oil or a mixture of alcohol and water. Here it's being done to liquid air. And you don't need a Bunsen burner to heat up the air because this boiling point is so low that room temperature is enough to start boiling the gases. Right, so the test tube contains air. Liquid nitrogen is used to cool the air down. The air in the tube condenses, making liquid air. It starts to warm up. When it reaches minus 197, the nitrogen in the air boils. All right, so it's warming up from minus 200 to minus 197, and the nitrogen starts to boil. Pure nitrogen gas is given off. Then, as it continues to warm, when it reaches minus 180, the oxygen boils, and then oxygen gas is given off. Okay, so air can be separated into oxygen and nitrogen. Right, okay, how much of that could you understand? Here's the explanation, but it's jumbled up. Pause the video, put the sentences in order to see if you can reconstruct that explanation. Pause the video now. Okay, here we go with the answers. It was E first, air is cooled until it becomes a liquid. Then C, the liquid is allowed to warm up again. F, nitrogen turns into a gas first. D, because it has the lowest boiling point. G, pure nitrogen is collected. Then B, oxygen turns into a gas second. H, because it has the next lowest boiling point. Then A, pure oxygen can then be collected. Okay, right, but how much of each gas is in air? Now, it turns out that air is around 78% nitrogen. So the mixture is mostly nitrogen. Oxygen makes up 21% of the mixture. The third most abundant gas in the air is actually a gas called argon. That's another unreactive gas. It used to be used inside light bulbs, and that makes up 1% of the air. There are other gases in air, and carbon dioxide makes up 0.04% of air. We'll talk more about carbon dioxide later in the topic when we look at global warming and climate change and burning fuels. So nitrogen has the formula N2, 78% of air. Oxygen, O2, 21% of air. Argon has the formula Ar, 1%. Carbon dioxide, CO2, 0.04%. Now here's a visual representation of the molecules in air. Molecules are small groups of atoms bonded together. Some of them are elements, some of them are compounds. The whole thing together is a mixture. A mixture is a collection of more than one substance that can be easily separated. All mixtures can be separated. Right, and each gas in the mixture is an element or a compound. So let's look at which one is which. Now, an element is made of one type of atom only, but a compound is made of more than one type of atom bonded together. We're going to go through the gases in air, and for each gas on the following slides, can you please say if they are elements or compounds? Pause the video if you need to, or just let it run and see if you can keep up with it. Okay, so nitrogen is an element made of one type of atom only. Oxygen is an element made of one type of atom only. Carbon dioxide, more than one type of atom bonded together, means it is a compound. Water, small amount of water vapor in the air, made of more than one type of element, more than one type of atom bonded together, so it is also a compound. And then finally, argon, made of separate atoms, not molecules, but all the same, one type of atom only, it is an element. So let's summarize that. Elements are made of one type of atom only. You can see that from the chemical formula, only one symbol. Remember that each element starts with a capital letter. If there's a small lowercase letter, it's part of the same symbol. So Ar stands for argon. It's not two separate atoms. Ar is the symbol for argon. Compounds made of more than one type of atom bonded together, like CO2, carbon and oxygen bonded together. H2O, hydrogen and oxygen bonded together. And you can see there more than one type of atom, more than one capital letter in the chemical formula. Okay, pause the video and match the definitions. Match the words to the meanings. Pause it now. Here we go with the answers. 1, mixture is B. 2, element was C. And 3, compound was A. Now, putting all that together, mixture, element, compound, okay, we need to think about, why is air known as a mixture of elements and compounds? Can you put that all together into one explanation? So pause the video, try and say it out loud. You don't have to write it down. Just think what you would say in a sentence. Why is air known as a mixture of elements and compounds? Pause it now. Here we go with the answers. What did I say? Air is a mixture because it can be separated into more than one substance. In the mixture are elements and compounds. For example, nitrogen, oxygen, and argon are elements because they are made of one type of atom only. Carbon dioxide and water are compounds because they are made of more than one type of atom bonded together. So in my answer, I've included the meaning of mixture, the meaning of elements, the meaning of compounds, and some examples. Right, before we do the writing task, a hinge question to check your understanding so far. What are elements and compounds? Which is the correct definitions? A, B, C, or D? Pause the video until you work out your answer. Go for it. Here we go with the answers. The answer is, well, B is good. It's kind of correct, but it doesn't say that compounds are bonded together. So what's a better version of that? C is a better version of that. Elements are made of one type of atom. Compounds are made of more than one type of atom bonded together. The best answer is C. We need to include those words bonded together in the definition of a compound. Okay, here we go with the writing task. Put the driving question at the top of your work. And what I would suggest you would do is do a little table like this for orange and green. Orange is naming and giving the chemical formula of the four gases. So that's the recall, the memory for this lesson, describing and memorizing key facts. And then the main idea of this lesson, what are the percentages of each gas in the air? If you can't remember, you can always rewind and check it out earlier in the video. And I would put that into a table like this. Then explain why air is known as a mixture of compounds, of elements and compounds, and maybe do a little sketch, do a little diagram of what the molecules in air look like. Then the extension, how do we use distillation to separate air into pure gases? Pause the video for as long as you need and put your best effort into this work, please. Good detail in your answers. And then in a few seconds' time in this video, the answers will appear. But don't look at the answers until after you've tried to do your own work, please. Go for it, Year 7. Here come the answers. Okay, remember to tick your work and write in anything you didn't think of. Here we go. The gases: nitrogen, N2, 78%. Oxygen, O2, 20%. Argon, AR, 1%. Carbon dioxide, CO2, 0.04%. Okay, why is air a mixture of elements or compounds? It's a mixture because it can be separated into more than one substance. In the mixture are elements and compounds. Elements include nitrogen, oxygen, and argon because they are made of one type of atom only. Carbon dioxide and water are compounds because they are made of more than one type of atom bonded together. Here's my diagram of the molecules. N2, you can always write N, N. O2, O and O. CO2, you can write C with an O and an O. An atom on its own, that's argon there. So we've got nitrogen, oxygen, carbon dioxide, and argon. And notice I've put in a bit more oxygen than the others, and then quite a lot of nitrogen into my diagram. Right, the extension, really difficult this. Well done if you've had a go at this. Air can be separated into pure gases by cooling air until it becomes a liquid. This is done using liquid nitrogen at minus 200 degrees C. The liquid is allowed to warm up again. Nitrogen turns into a gas first because it has the lowest boiling point. Then pure nitrogen can be collected. Oxygen turns into a gas second because it has the next lowest boiling point. Pure oxygen can be collected. This overall method is called distillation of liquid air. If you've had a really good go at that, well done for trying it. Remember, you can add in any other points to your answer that you need to. You can always write a bit more detail now as you're marking it. Okay, today I achieved. Today I achieved describe, because I could name 4 gases in air and the chemical formula. Today I achieved explain, because I could summarize the percentage in the atmosphere of each gas. Today I achieved use, because I could explain why air is known as a mixture of elements and compounds. Today I achieved combine, because I can explain how air can be separated into pure gases using distillation. Well done for your effort and your work today, Year 7. Let's keep that effort going with good detail in your work. But please don't forget to go back on to show my homework and do the 10-question quiz for this lesson. Okay, thank you very much. Well done. This was Lesson 4, What is Air?